Okay, so get this. Imagine, right, a line of garbage trucks
Hmm.
filled with nothing but like old phones, laptops, all that electronic junk.
E-waste.
Yeah, exactly, e-waste. But here's the thing, there's so much of it.
Yeah, that's a lot.
We're talking like 62 million metric tons worth. Enough to, get this, circle the entire planet.
It's a pretty startling visual when you think about it that way.
It is, right, like a giant e-waste necklace around the Earth.
Not a good look.
Not at all. And a lot of that e-waste, it contains precious metals, like gold.
Absolutely. Gold is vital for our tech.
Phones, computers, even those little USB-C connectors. Gold, gold, gold. But the problem is getting the gold out, it's not so easy.
No, it's not. Current methods, they're kind of like, well, using a blowtorch to open a walnut.
Effective.
Sure, effective, but messy.
And dangerous.
Definitely.
So that's what we're diving into today.
A deep dive into gold recovery.
Why the old ways are so bad. And the really cool thing, researchers might have found a total game changer.
They might have.
A sponge.
Yeah, a sponge.
That can pull gold from e-waste.
Cleanly and efficiently.
So that's our mission. How it works, why it's better, and what it could mean for, well, the future of, gold, e-waste, everything.
Well, the sponge itself, it's pretty amazing. It's made from two main things. Graphene and chitin.
Graphene I've heard of, but chitosan.
You might not know this, but chitin, it's derived from shrimp shells.
Shrimp shells? No way, that's incredible. So we're taking something that's usually like tossed out trash.
Right.
And using it to recover precious metals. Already sounds like a win for like sustainability.
Definitely a plus on that front.
But okay, how does this shrimp shell sponge actually work?
So they did this experiment. They passed a solution, had gold ions in it, through the sponge. The solution, it starts out yellow.
Okay.
But then as that sponge does its thing, the solution turns completely clear.
Wow, that's visual.
Right. The sponge is grabbing those gold ions, pulling them right out of the liquid. And then the chitosan, it acts as like a reducing agent.
Yeah.
And it helps transform those ions back into solid gold, trapped right there on the sponge's surface.
So it's not just filtering, it's like recovering the gold in a usable form.
Exactly.
That's a huge difference. We're not talking about your average kitchen sponge here, are we?
Nope. Definitely not your typical sponge. The key to this one, it's its ability to absorb the gold.
Absorb.
Which is different from absorbing it.
Okay, now I'm confused.
So think of absorption, like a regular sponge soaking up water.
Okay, got it.
Absorption is different. It's more like edging tiny magnets on the sponge's surface, attracting and holding specific particles.
Ah, I see. So it's not soaking it up. It's like specifically grabbing it.
Exactly.
But how effective is this thing? I mean, can a sponge really make a dent in like this massive e-waste problem we have?
Well, the results, they're pretty impressive. This sponge recovered up to 99.5% of the gold from those solutions, even when the gold concentrations were super low. And get this, an independent expert, they called it, quote, a record high value.
Wow, 99.5%. That's almost a perfect score. You'd think something that effective would have to be like incredibly complicated,
Right. But it's actually pretty simple. Part of what makes this sponge so interesting is the process. It uses self-assembly.
Self-assembly, like it builds itself.
Basically, the components, they naturally arrange themselves into the right structure, like they have a built-in blueprint.
So nature's doing a lot of the work here. This is starting to sound like something out of like a science fiction novel. Shrimp shells, self-assembling sponges, gold recovery. It's almost too good to be true, right?
Well, there are some hurdles, for sure.
Like what?
One of the big ones is cost. Graphene and chitosan, they're not exactly cheap ingredients. And then there's the issue of scale. The researchers are still working on how to, make this work on a large industrial level. They've got the concept, but getting it to that next level, that's the challenge.
It's like you have an amazing recipe, but trying to cook it for 1,000 people, not just your family.
Exactly.
But even with those, hurdles, this still feels like a massive breakthrough, right? I mean, are there any other, drawbacks, things to consider with this technology?
Well, one concern is the long-term stability. Will it hold up to repeated use? Or will it degrade, lose its effectiveness? That's something they'll need to investigate.
Durability testing. Got it. And I mean, e-waste isn't just pure gold dissolved in water. Are there concerns about, can it pick out the gold from the, the real mess of e-waste?
That's another good point. It's shown great selectivity for gold in the lab, but how it performs in a real e-waste scenario, that needs more study.
Makes sense. But even with all that, the potential here is huge. We're talking about, turning what we think of as waste into like a valuable resource, cleaning up a major environmental, hazard, and maybe even making the tech we rely on, well, more sustainable. It's almost like, I don't know, alchemy, turning trash into treasure.
It is a powerful image, and it really highlights how innovation, it often comes from unexpected places. We tend to think of high-tech solutions as being, complex, expensive, but sometimes the best answers, they're surprisingly simple.
And even inspired by nature.
Right.
Speaking of simple, I'm still kind of curious about how this sponge actually works, on a molecular level.
Yeah.
Earlier you mentioned adsorption. I think it would be good to get a clearer picture of what's going on at that, super tiny scale.
Sure. Imagine the surface of the sponge, like a microscopic landscape with valleys and peaks, created by, how those graphene and chitosan molecules are arranged.
Okay, so like a tiny, intricate world.
Exactly. Now picture those gold ions dissolved in the liquid flowing over that landscape. And the way the sponge's surface is structured, those gold ions are drawn to specific sites, like little docking stations. And they latch on, hold tight, thanks to the unique chemistry happening at that nanoscale level.
So it's not just about having a big surface area. It's about like creating a surface that's specifically designed to like grab those gold ions. It's like a custom-made trap.
Precisely. And that's where the combination of graphene and chitosan, that's what makes it work. The graphene provides the structure, that strong framework, and the chitosan, it creates those specific binding sites.
So it's like a team effort. And then the chitosan also, it helps convert those ions back into solid gold particles, right? So it's like capture and then solidify.
Exactly. 2 steps. It's a really remarkable example of how, combining different materials can lead to these highly effective solutions. And the fact that we're using something as, ordinary as shrimp shells, that makes it even more impressive.
It really shows the potential of like bio-inspired design. Yeah. Nature has been solving problems for, well, millions of years, and we're just beginning to like tap into that wisdom. Who knows what other unexpected materials are out there just waiting to be discovered and put to good use.
That's an exciting thought.
We often hear about, rare earth metals and things like that as being essential for our technology, but maybe the next big breakthrough will come from something as common as, I don't know, coffee grounds or banana peels.
I wouldn't rule anything out.
It's like we need to retrain our brains, see waste as a resource, look for potential what others just see, problems.
Absolutely. And this sponge, it's a great example of what's possible when we, embrace that kind of thinking.
Absolutely. But before we go too far down that road, let's get back to basics for a second. Those traditional methods, the ones we said are so problematic, why are they so bad? And how does this new sponge tech, how does it compare?
Well, those traditional methods, they're really rough on the environment. They use strong acids, toxic chemicals, things like cyanide, to dissolve the gold.
Cyanide. Yikes.
Yeah, it's nasty stuff. It can contaminate water, and it's a real risk to people's health.
It's like using a sledgehammer to crack a nut,
Yeah.
You get the job done, but you cause a lot of damage in the process. This sponge, it's like a much gentler, more sustainable approach.
Exactly. And it's not just the environment. Those traditional methods, they're very energy intensive.
So they take a lot of power to run.
Lots of heat, multiple steps.
Whereas this sponge, it just sits there and passively grabs the gold.
Much simpler, much more efficient.
Like comparing, I don't know, a gas-guzzling truck to an electric vehicle. One's brute force, the other's all elegant and sleek.
I like that analogy.
But we did say earlier that the sponge technology, it's still early days.
It is.
So what's next? How do we get this out of the lab and into, the real world?
Well, researchers are focusing on 2 main things. Scaling up the production, obviously, and then optimizing the sponge's performance.
So figuring out how to make a lot of it.
Yeah.
And making sure it works, really well.
Exactly. It's got to be able to handle real e-waste, not just those perfect solutions in a lab.
Right. The real world test. But even with those challenges, it's hard not to be really excited about this, right?
Absolutely.
It really feels like it could change things.
It does. It's a real testament to human ingenuity.
Our ability to, solve problems.
And to find creative solutions, even for problems that seem really tough.
It's a reminder that even small things, like a sponge, can make a big difference. But let's step back for a minute. We've been talking about this amazing technology, but what about the average person? Why should they care about a gold capturing sponge? How could this actually, impact their lives?
That's a great question. and it's an important one.
Because at the end of the day, technology, it should benefit people, right? So what's in it for them?
Well, for one thing, it could mean a reduction in the environmental risks and the health risks, too, that come with those old gold recovery methods.
Because of all those toxic chemicals.
Exactly. By shifting to cleaner, more sustainable methods, we create a healthier environment for, well, everyone.
That's a win. But are there any, economic benefits for the average person?
Oh, definitely. The more efficiently we can recover gold from e-waste, the less we have to rely on, traditional gold mining.
Which is, really bad for the environment.
Yeah, it's super destructive. Plus, it often involves, exploitative labor practices in developing countries.
So this sponge, it could actually contribute to a more, ethical and just, gold industry.
It could. It's not just about environmental benefits. It's about creating a fairer system for everyone.
I like that. So it's more than just a cool science project. It's about, making better choices.
Exactly.
And realizing that those choices, they have consequences.
Consequences for people, for the planet.
So what we're saying is the choices we make as individuals, they matter. Whether it's, supporting responsible e-waste recycling programs or advocating for these kinds of technologies, we all have a role to play in building a better future. But we'll delve further into that in the next part of our deep dive.
We'll pick up right where we left off and explore the broader implications of this technology, how it could change how we handle e-waste, and how it fits into the bigger picture of a truly circular economy.
Stay tuned, everyone. We've got a lot more to uncover. So we're back, and we've been talking about this amazing new material, a sponge, right?
That's right.
That can pull gold from e-waste. Not only is it super efficient and it grabs almost all the gold, but it's also way cleaner than those old methods, the ones with all the toxic chemicals.
Much cleaner.
Plus, it's made from shrimp shells. Talk about, turning trash into treasure.
It's really quite remarkable how this challenges our assumptions about innovation, where it comes from. We often think high-tech equals complex engineering, rare materials. But this sponge shows us the power of, bio-inspired design.
Using stuff we already have, mimicking nature.
Exactly.
Nature already knows how to do things sustainably, efficiently, and we're just playing catch-up. We've talked a lot about, the environmental benefits, but I'm curious about the economics of it all. Could this sponge actually, make a dent in the global gold market?
It really has the potential to shake things up. Think about it. Right now, we're so reliant on traditional gold mining.
Expensive, yeah.
Environmentally damaging, often linked to questionable labor practices.
Not good.
Not at all. But this sponge technology, it could be a much cleaner, more cost-effective way to get gold, especially if we can scale it up to handle all that e-waste we generate.
So instead of digging for new gold, we could be, mining our landfills. That's a pretty wild idea.
It is. And it's not just gold, either. Think about the other valuable stuff in e-waste. Platinum, silver, all those rare earth elements. The ones that are crucial for our tech.
Yeah, they're in everything.
If this technology could be adapted to recover those too, huge impact.
On supply chains, on everything.
Exactly. It's like those mountains of e-waste, they become urban mines, full of resources, just waiting to be, unlocked.
I love that, urban mines. And that ties into this whole idea of a circular economy, right?
Absolutely.
Designing products with the end in mind, making it easier to, take them apart and recover the valuable bits. Imagine, our old electronics, not as trash, but as a source of valuable material.
A resource stream constantly being reused.
That's the future right there.
Yeah.
But, okay, let's be realistic. What about those challenges we talked about? Cost, scaling up production, making sure it works in the messy real world, not just the lab. Are those really roadblocks? Or are they just, speed bumps on the road to this sustainable future we're talking about?
They're challenges for sure. But I'd say they're solvable challenges. Researchers are making progress already, tackling those issues head on.
Like how?
Well, for instance, they're experimenting with, different ways to produce the graphene and chitin more sustainably, more cost-effectively, and they're working on improving the sponge's selectivity.
So it can really hone in on the gold, even when it's surrounded by, a jumble of other stuff.
Exactly.
It's like fine-tuning the recipe, making sure it works just as well in a big factory as it does in, a tiny lab beaker.
A good analogy.
But even with those challenges, it's hard not to get excited about, the possibilities, the ripple effects this could have.
It's pretty amazing to think about. What if we could create a closed-loop system, for electronics, where the materials are always being recycled, reused, we'd minimize waste, and we wouldn't have to rely so much on mining.
A total revolution in how we think about, the stuff we use every day. But let's bring it back to like the individual listener for a second. What can people do right now, even before all these high-tech solutions are available, to support this move towards, a more sustainable way of handling e-waste?
Well, first and foremost, be mindful. Think about what you buy, how you get rid of it.
Support companies that are doing things the right way, ethically, sustainably.
Right. Choose products that are built to last, that can be repaired, upgraded, and when it's time for an upgrade, don't just toss the old stuff in the trash. Recycle it responsibly.
Through those certified programs, right?
Exactly. Or donate it to organizations that refurbish electronics. Give them a second life.
So it's about, like, being a conscious consumer.
Thinking about the whole life cycle of a product. Where it comes from, what happens to it when you're done with it.
Making choices that support, that circular economy we were talking about.
Exactly. And remember, even small actions, they add up. If millions of people are making those choices, advocating for better solutions, that's how we create real change.
Demand for change, voting with our wallets, right?
That's it.
It's empowering, knowing that we're not just along for the ride. We can actually do something.
We can all be part of the solution.
But for now, let's get back to this amazing sponge and all its potential to transform how we handle e-waste.
One of the things that's key to understanding this sponge is that it's not just a filter. It's not passive.
Right.
It's a dynamic material with unique properties that let it selectively attract and bind those gold ions.
We talked about it earlier, but could you, remind our listeners how this adsorption thing works? I think it's worth, really digging into what makes this sponge so special.
Of course. Imagine a surface covered in tiny magnets, all pointing in different directions. Now, sprinkle iron filings over that surface.
Okay, I can picture that. They would stick, right? Two magnets.
Right. And that's similar to what's happening with those gold ions in the sponge's surface. The graphene and the chitosan, they create this surface with specific chemical properties. So it attracts and binds the gold ions, pulls them right out of the solution.
So the gold ions are magnetically drawn to the sponge, but what keeps them there? Why don't they just float away?
That's where the chitosan steps in. Remember, it's a reducing agent. It can give electrons to other molecules.
Ah.
And it does that to the gold ions, neutralizes their positive charge.
So the chitosan is stripping away the gold ion's stickiness to the water.
Exactly. And once they're neutralized, they're not soluble anymore. They can't stay dissolved in the water. So they start to clump together, form tiny gold particles right there on the surface.
It's a two-step process: capture, then solidify. It's a really clever combination of, chemistry and material science.
It is. And it shows how important it is to understand, the basic properties of materials, how we can use them to get specific results.
It's like having a toolbox full of different tools, each one with its own special use. And by putting those tools together in the right way, we can build some incredible things.
I like that. And I think that same idea applies to the whole e-waste challenge. It's not enough to just recycle. We need to rethink the entire life cycle, how we design things, how we dispose of them.
Design for durability, for repairability, use materials that can be recycled or repurposed.
That's it. Shifting away from this linear model, take, make, dispose, towards a circular model where the materials are always flowing back, being reused.
It's a big challenge, but we can't ignore it. And this sponge, this gold-capturing sponge, it's like a little beacon of hope, showing us that innovation can come from, anywhere.
Nature is full of solutions if we know where to look.
We can learn so much from nature and apply those lessons to our own technology.
Absolutely. And it's important to remember, this isn't just some abstract scientific thing. This has the potential to change lives, make the world better, cleaner, fairer.
It's about more than just getting gold. It's about creating a better future for everyone. But let's not get ahead of ourselves. We've talked about all the good stuff, the potential. What about the limitations? Are there any downsides, things we need to be cautious about?
That's a really good point. No technology is perfect, right? And in this case, one concern is, how long will this sponge last? Will it hold up to repeated use?
Durability, right. Making sure it doesn't fall apart or stop working after a few cycles.
Right. And then there's the question of selectivity. It's great at grabbing gold in the lab, but can it do that when it's surrounded by, all the different metals and contaminants you find in real e-waste?
The real world mess.
Exactly. And we also need to consider, what's the environmental impact of making the sponge itself?
Because even though the materials are, bio-derived, we have to make sure the whole process is sustainable.
We have to look at the big picture, the whole life cycle, from production to disposal.
To be sure, it's truly a greener alternative to those old methods.
That's right. A holistic approach, weighing all the factors.
So it's not a silver bullet.
No, but it's a very promising step in the right direction.
A reminder that even with the best innovations, there are always trade-offs, challenges to think about.
Absolutely. And that's why ongoing research is so important, to address those limitations and make sure it's ready for the real world.
And I'm sure there are scientists all over the world working on those very questions right now.
I have no doubt.
It's exciting, to think about the possibilities. This gold-capturing sponge, it could really help us create a more sustainable future.
It's a testament to human ingenuity, our ability to come up with solutions for these really complex problems.
Well said. This has been, a fascinating dive into the world of e-waste.
Gold recovery, bio-inspired design.
We've gone from the huge scale of the problem to the tiny details of molecules interacting, and we've talked about the challenges, the opportunities, the economics of it all.
And the potential to change how we think about waste and resources.
But before we get too carried away with the excitement of this discovery, let's pause for a second. Acknowledge the real challenges we still face. We've talked about cost, making enough of this sponge and making sure it can handle, real e-waste, not just the stuff in a lab. Those are pretty big challenges, right?
They are. But I think it's important to remember, this sponge, as cool as it is just one piece of the puzzle.
Right, we need a whole bunch of solutions working together.
Exactly. Better design, so products last longer, responsible recycling, obviously, and then technologies like this sponge to recover the valuable materials.
Speaking of recovering, this sponge is great at grabbing gold, but could it be, tweaked to get other stuff, like other precious metals or those rare earth elements everyone's talking about?
That's a question researchers are definitely looking into. The idea behind it, that selective absorption, it could work for other materials too.
So it's like adjusting the recipe, right, to attract different flavors of metal ions.
It's a good way to think about it.
Imagine a whole library of these sponges, each one designed to recover a specific thing from e-waste.
It's an exciting possibility.
That could be huge, not just for electronics, right?
Oh, absolutely. Think about electric vehicles, renewable energy tech, even aerospace. They all rely on these materials that are, well, they're getting harder to find.
Yeah.
And more expensive.
If we could recover them from e-waste, that changes everything.
It would have a massive impact economically, even geopolitically.
We're talking about a whole new way of thinking about resources, right?
Exactly.
Not digging up new stuff all the time, but mining our own waste.
Closing the loop.
Yeah.
Creating that circular economy we've been talking about.
And this sponge, it shows us that it's possible. It's not just, good for the environment. It's about creating a future that's more resilient, more sustainable.
A future where we're not constantly depleting the planet's resources.
I'm getting this feeling that this sponge, it's more than just a scientific discovery. It's like a symbol of something bigger.
What do you mean?
It reminds us that innovation can come from anywhere. And that nature, it has so many solutions, we just have to pay attention. And that we can actually, build a better future.
I like that. And I think it's so important for people to remember that, they're not helpless in all of this. We can all do something.
It's not just up to the scientists?
Right. Not at all. Our choices matter. Whether it's, what we buy, what companies we support,
right,
or just spreading the word about responsible e-waste management.
Right. It's about realizing that every little action, it adds up.
Absolutely. Choosing to buy things that last longer, that can be fixed, supporting companies that are doing the right thing, recycling responsibly, those choices make a difference.
It's about demanding change. Right.
And voting with our wallets.
Yeah.
And staying curious, informed.
Learning about the problems and the solutions.
The more we know, the more we can do.
Well said. This has been an amazing deep dive.
We've covered a lot.
The e-waste problem, the science behind this sponge, all the possibilities it opens up.
It's been a fascinating journey.
And I hope it's inspired you, the listener, to, think differently about this stuff, about e-waste, about innovation, about what we can do to make the world a better place.
We all have a part to play in building a more sustainable future.
Couldn't have said it better myself. Remember, the future isn't something that just happens to us. We create it through our choices, our actions. So until next time, stay curious, keep learning, and let's keep working towards that brighter future.